So hey guys, welcome back to our channel. But so today we're gonna learn about polynomials, a second chapter in Ncrt Mathematics textbook. So today our objectives, that is what we're gonna learn, is going to be types of polynomials, geometric meaning of the zeros of a polynomial, relationship between zeros and coefficients of a polynomial. Okay, now we're going to see the types of polynomial. There are basically three types of polynomial. First, linear polynomial, which means the highest degree in a polynomial should be 1. That is, the highest power of a variable in an equation should be 1. Second, quadratic polynomial, which means the highest power of a variable in equation should be 2. And for cubic polynomial, that is the highest power of the variable in an equation should be 3. Yeah, so here are some examples for all the three cases. So first case, linear polynomial, you can see the highest power of variable in all the equation is 1. And for the second case, that is quadratic polynomial, the highest power of the variable in all the equation is 2. And for the third case, cubic polynomial, the highest power of a variable in all the equation is 3. So now we're going to see about the geometrical meaning of the zeros of a polynomial. So y is equal to px, where x is the variable. It so what you're going to see is that we can find the number of zeros for the respective equation without factorizing them. We can directly find it from the graph. So basically, we have to, since x is a variable here, we have to see how many times does the line intersect over the x-axis. So for the first image, there are two graphs. In both the graphs, the line intersects through like two times through the x-axis. We can see 1 and 2. Even over here we can see 1 and 2. Whereas in the second image, we can see the line only like passes through the y-axis. It does not intersect or like touch the x-axis in both the graphs. So that means the 0 for the second image for both the graphs is 0. Like the number of zeros is actually 0. Now here are some examples from exercise 2.1, which is from Ncrt textbook. So find the number of zeros of p of x in each case. So p of x, which means x is the variable. So for the first graph, we can see the line does not pass through the x-axis, which means the number of zeros is 0. And for the second graph, we can see it just passes through like only once through the x-axis. That means there's only one zero. That means it's a linear equation. And for the second, for the third graph, we can see it passes through like it passes thrice, three times through the x-axis. That means here 1, 2, and 3. That means that means there are three number of zeros. Number of zeros is 3, so which makes it a cubic polynomial. Like for cubic polynomial, the number of zeros is 3. For quadratic polynomial, the number of zeros is 2, and for the linear polynomial, the number of zeros is 1. So for the first graph, we can say it's a for the second graph, we can say it's a linear polynomial, and for the third graph, we can say it's a cubic polynomial. Yeah, in the fourth graph, we can see the line passes like twice through the x-axis. That means which makes it like the number of zeros is 2, and we can also say that it's a quadratic equation. And in the fifth graph, the line passes through like it goes like 1, 2, 3, 4, 4 times. It passes 4 times through the x-axis. So that means the number of zeros is 4. And like we call it a polynomial generally. Any like equation which has a power more than 3 is known as a normal polynomial. There's no specific name. We can just call it a polynomial. And for the sixth graph, we can see that the line passes like 1 2 3 thrice through the x-axis. Like it does not like it it should it's not necessary that it should pass through the x-axis. It's also okay that if it touches the x-axis, just touch over here just like this. It's not necessary that it should only pass through it or something like that. Okay, so it can touch the x-axis or at the same time pass the x-axis. So the number of zeros is 1 2 and 3. That means it's a cubic polynomial. So our next topic is going to be the relationship between zeros and coefficient of a polynomial. So what is a coefficient? A coefficient is a constant which is associated with a variable in a term. So in this term, that is ax square, x is a variable and a is a constant and the coefficient is a. And similarly for bx term, the x is the variable and b is the coefficient. And this ax square plus bx plus c equals 0 is the general form of the quadratic polynomial. And on factorizing a quadratic polynomial, we get the form k into x minus alpha into x minus beta, where k is a constant and alpha and beta are zeros. So on simplifying them, like on multiplying, we get this form finally. And in this equation, we can see that the coefficient of x square is k and the coefficient of x is minus k into alpha plus beta, and k alpha beta is a constant, which is similar to our general form. So that means we can equate the coefficients, right? So that means coefficient of x square or like is a and k. So on equating them, a equals k. And similarly equating x coefficient, we get b equals minus k into alpha plus beta, and equating the constants, we get c equals k alpha beta. So our main aim is to establish a relationship between zeros and the coefficient of a polynomial. So now to establish a relationship, we need to cross multiply a and b. So on cross multiplying them, that is a equals k and b equals minus k into alpha plus beta, we get this equation, that is minus a into k into a, that is alpha plus beta equals b into k. And we can see that k is common, like in like on both these sides, that is RHS and LHS. We can cancel k on both the sides, and now we get minus a into alpha plus beta equals b. Now we are gonna bring the constants on I mean like bring the coefficient to one side and the zeros to another side. So we can see that alpha plus beta, they both are zeros, they are already in the LHS side, and b is a coefficient in the right side, so it's easy for us to move a to the right side. So therefore, like we can see that we have established a relationship between zeros and coefficient. And yeah, so now we can also establish another relationship, that is cross multiplying a and c. Now a equals k and c equals k into alpha beta. So now on cross multiplying them, we get this equation, and we can see that k and k like LHS and RHS, they both have k in common, so we can cancel them. And now we're going to separate the zeros and coefficient. On separating them, we get alpha beta equals c by a. I hope you have understood till now. Okay, now let's see an example related to our previous concept. Find the zeros and also verify the relationship between zeros and coefficient for the quadratic equation, that is x squared plus 5x plus 6. So to the very first step to find the zeros is factorizing the given equation, and the simplest method for it is splitting the middle term. and I hope you guys are familiar with the concept that is splitting the middle term. And on factorizing and splitting the middle term, we get this form of equation, that is x plus 3 into x plus 2 equal to 0. And on equating x plus 3 equal to 0, we get a first 0, that is minus 3, and a second 0 is minus 2. So now we can see here minus 3 and minus 2 are our zeros, and alpha is minus 3 and beta is minus 2, and k equals 1, and 1 is a constant over here. Yeah, it's not much of importance. And now we can see that oh no, from the equation we can see the coefficient of x square is 1, that is a equals 1, and the coefficient of x is 5, that means b equals 5, and the constant is 6, c. And yeah, now we have found our values for alpha and beta, and also we have assigned the values for a, b, and c from the given equation. Now let's verify the relationship between zeros and the and its coefficients, and the coefficients of the quadratic equation. And yeah, now our first relation, that is uh, alpha plus beta equals minus b by a. Now RHS, we'll take alpha plus beta as a RHS. On solving it, we get minus 3 plus of minus 2 becomes minus 2, which equals minus 5. Whereas our LHS is minus b by a, that is our minus b. So here b is 5, so minus b is minus 5 by a, and a is 1, right? Coefficient of x square is 1, so 1, which equals minus 5. Since RHS equals LHS, we have proved our first relation, like we have verified our first relation. So hand I mean sorry, therefore we have, oh sorry, it's a bit hard. We have verified our first equation. Okay, next we are going to verify a second relationship, that is alpha beta equals c by a. Now we'll take alpha beta as our RHS and c by a as our LHS. Now alpha beta is minus 3, basically the product of our zeros, that is minus 3 into minus 2, which equals 6, and LHS c by a, c is 6 and a is 1, so 6 by 1 equals 6, and therefore we have proved that RHS equals LHS. So we have proved our relationship, we have verified our relationship between the zeros and the coefficients. And now we're going to see the relationship between zeros and coefficient for a cubic polynomial. So the general form of a cubic polynomial is ax cubed plus bx squared plus cx plus d equals 0. So now it's similar to that of our for a quadratic equation, but with some few changes and an extra equation, that's it. And we can see this first relationship is almost similar to a first relationship for a quadratic polynomial, except we just add an extra gamma, which is for the third zero. As we all know that for cubic polynomial we get three zeros, right? So gamma is for the third zero, and in the third equation we can see that that this equation is also similar to a second relationship in a quadratic polynomial. We have, except for that, we have added an extra gamma, like we have multiplied an extra gamma for the third zero. And the second equation is new for us, and so this equation is alpha beta plus beta gamma plus gamma alpha equals c by a. So these three are a relationship between zeros and coefficients for a cubic polynomial. Okay, now let's view an example for a like for a cubic polynomial. Like this is a very important question. Um, so they've asked us to verify that 3 minus 1 minus 1 by 3 are the zeros for the given cubic polynomial, which is very easy. We just need to substitute the zero, the given zero, that is first zero is 3 in place of x, and on substituting the resultant value should be 0, and we can see that on substituting 3 as x in the cubic polynomial we get 0, and when we substitute the second 0 which is minus 1 we get 0, and on substituting our third 0 which is minus 1 by 3 we get 0. And now the most important part, that is the second part of question. They've asked us to verify the relationship between zeros and the coefficients. So now since we know how to verify the relationship for quadratic polynomials, it's going to be easy for the cubic polynomial. Same way, we just substitute the value for alpha, beta and gamma in RHS, and we are going to substitute the corresponding the relation, that is for alpha plus beta plus gamma equals minus b by a. So here our b is minus 5 and our a is 3. So on substituting we get, over here on substituting values for alpha plus beta plus gamma we get 5 by 3, and on substituting values for minus b by a we get 5 by 3, that is minus of minus 5 by 3, which gives us 5 by 3. So now LHS equals RHS, so hence we have verified our first relation. And for the second relation, we are going to substitute the values for alpha, beta, gamma for the respective places, and over here we're going to substitute the value for C and A, and we get LHS equals RHS, and so hence verified. And yeah, like it's similar to that of our quadratic polynomial method, how we verify it. We just need to substitute the values, and we have to see whether LHS equals RHS. If it's equal, means that means we have verified the relationship. Okay. Yeah, and it's similar for the third relation also. You have to just substitute the values and establish. And if we just check whether the resultant value is same for both LHS and RHS. Yeah, thank you for watching the video, and I'll given a link below for for extra questions along with solutions. And if you have any doubt in any of the question, you can email me. I've given the email ID also below. And yeah, stay tuned for the second part and as well as for more chapters. Thank you.